In section 9.3, we will focus on simple discount notes. Hopefully after this lesson, you are able to describe basic terms that's associated with simple discount notes, including bank discounts, proceeds, and face value, etc., and then be able to find those. Let's jump into it. So here are some terms. Simple interest notes and simple discount notes, they are two different things. Previous sections we talk about when we talk about loan, interest, maturity value, those are all simple interest notes. Now, simple discount notes is different. By the way, simple interest notes is like when you get the loan from the bank, that's the principal, okay? That's also face value, that's the number written on the note. And the interest usually is not written on the note, it will be, you have to calculate it. So the principal that you get from the bank plus the interest, that will be how much you pay back to the bank when it is mature. So principal plus interest rate is going to be maturity value. Basically, let's imagine a hypothetical scenario. So simple interest note is like this. Suppose you borrow $100 from the bank. So the bank will give you $100. That's the face value, okay? Face value. And then suppose a year later you have to pay back. The loan mature and then you have to pay back. You have to find the interest. And when you pay back, that's the maturity value, right? Maturity value. Let's call it just M. M is the maturity value. Now, for a simple discount note, this is a little different. It will be the face value actually will be how much you will pay back. And the bank will deduct the interest from the face value up front and only gives you the remaining, which is called proceeds, to you. So basically the proceeds is the amount of money that borrower gets. Bank discounts, which is the interest the bank take away. So what the bank will deduct that from the face value. And maturity value is the total amount of the loan that you have to pay back. So in a simple discount scenario, in this case, so simple discount note scenario, say suppose you borrow $100. So the $100 is actually the face value, okay, face value. And the bank won't give you $100. The bank will take away the interest first. So it will deduct interest. And of course, you're gonna get, let's make a hypothetical number. Suppose the interest is like $10. Then you will only get $90, okay? So you'll only get $90 from the bank because $10 is taken away by the bank as interest. And a year later, how much you have to pay back? You're going to pay back $100. So basically you get 90 and you pay back 100 in this case. So this scenario is called the simple discount note. Discount will be taken. Discount means the interest. And this is called proceeds, how much you actually get. Okay. All right. Hopefully if you, probably my suggestion is pause for a little. Ask yourself, do you know what proceeds is? Are you able to describe it? Do you know what the bank discount is? Describe it. And in the simple discount notes, what is the face value? They are definitely different, right? They're definitely different compared to the simple interest notes. All right, so let's talk about some new formula here. Bank discounts, which is the interest charged by the bank. In this scenario, okay, we focus on simple discount notes. So how do you find the bank discounts? Basically, this is actually the interest again. It will be face value, which is this face value, how much you actually will pay back, times the discount rate, which is, again, discount is just the interest. We just name it differently. So the interest rate times the time, measured in years, by the way. This is again measured in the units of year. Don't you feel like it's pretty much the same as I equals PRT, right? P RT. This actually is similar structure. Bank discount, which is the interest. Face value, which is the how much on the note, times because in the simple discount notes, the face value is actually the maturity, how much you actually pay back at the end. So we'll use M to represent the face value. Discount rate is the D, we just call it D. Time is the time. So they have the similar structure compared to the simple interest formula and this formula. Okay. So again, B is the bank discount. So this is the bank discount. By the way, it's just the interest, okay? It's just the interest taken away by the bank. This is the discount rate, which is the simply interest rate. And M is the maturity value. Maturity, how much you pay back. Maturity value, which is the face value as well in this case. They're the same. And this is time in year, right? Time measured in the units of year. Now, how do we find the P proceeds? So P is the proceeds. That's I'm going to erase that so that it doesn't confuse you. The P previously P is principal. Here P is the proceeds. The proceed will be face value minus the bank discount. So the how much you're going to pay back and minus how much the bank will take away as interest. Then what you receive, that will be what you receive. So this will be P equals the maturity minus the bank discount. Obviously, if you know the proceed, if you know the bank discount, how do you find the maturity value? Maturity value will be just proceeds plus the bank discount. All right. So, well, it's important that you just don't just fly through here. It will be important for you to understand this relationship and the terms. All right, first example, Jim signs a simple discount note with a face value of $35,000 so that he can purchase a truck with plow for his snow removal business. The bank discounts the 10-month note at 9%. So basically this means this is the discount rate, how much the bank charges interest rate. And this is the length of the note, right, the term. And this is the face value, which is the maturity value, and how much Jim will have to pay back. We want to find the amount of discounts and proceeds. So the amount of discount is MDT, which is the 35,000, times the discount rate, which is 9%, 0.09, times the 10 month. Well, pause the video here to ask yourself, is this correct? Okay. Now you may resume the video. This is incorrect. Cannot be 10. How do you make it correct? Because keep in mind the T is measured in the units of year. You have to divide this by 12 because 1 year there are 12 months. It turns out this is $2,625. Okay. And so this is the bank discount. That means the bank, before the bank gives Jim money, they will deduct this interest or discount from this maturity value. So therefore, what's left is so-called the proceed. So proceed will be the maturity value minus the bank discount, which is 35,000 minus 2625. So it will be 32,375. This is so in summary, Jim will receive that upfront, and 10 months later, he'll repay back bank this much, and the interest he actually pays is this much. Okay. All right. The next question is: an employee borrows $7,000 from a bank to purchase some household items. She plans to repay the loan with a bonus she's supposed to receive in 85 days. So the time is here. This is the how much she needs, right? Okay, I mean, this is how much she borrows. If she borrows the money at 11.4%, find the discount and the proceeds. So when I see the term discount, I know we are talking about simple discount note. That's how we know that we use this formula. So the bank discount will be MDT, will be 7,000 times the D, which is the discount rate, 11.4.114, times, again, is this going to be right? Just multiply by 85 days? It is not right, right? You have to divide this by 360. And this is equal to $188.42, rounded. So therefore, the proceeds will be the maturity value minus the bank discount. So 7,000 minus 188.42, which becomes 6,801.58. So that means she will only receive $6,811.58, and but 85 days later she'll pay back 7,000 to the bank. All right, so let's do a couple more exercises before we look at the next topic. In order to plant Christmas trees in another field, Bill signed a note with a face value of $27,000 at 12% discount rate. So when you see that, you know we are talking about simple discount notes. Find the length of the loan in days, given that the discount is 1260. So this is the discount, right? This is the bank discount. This is the discount rate. And this is the face value. We want to find the length of the loan, which is the time. Now, if you remember, B is equal to MDT. You can always create your little circle right there, okay? So this means B is here, MDT is on the bottom. In this particular example, we are going to find the time. So hopefully you can now tell me what the formula is. Maybe you can pause the video, do a little thinking. So because we want to find the time, according to the circle, we'll have B over MD. And keep in mind, this is measured in year, right? In year. Okay. So therefore, this is going to be B is 1260. M is 27,000 times the discount, which is 0.12. By the way, this, if you do the algebra, this is going to be in the units of year. And let's take a look at, in the question it says, find the loan in days, right? So we have to convert this result into number of days. How do we convert it into number of days? You multiply by the days, 360. So this turns out to be 140 days. Check the math for me. All right, so let's take a look at the very last one. Jennifer needed $6,000 to start a web page design company and signed a 250-day note with a face value of $6,355.81. We want to find the discount rate. Okay, the discount rate, that means we want to find in this little chart, we want to find the D, discount rate, right? So therefore the discount rate is equal to B over MT. So B over MT. And B is the discount. What is the discount here? Let's see. What is the discount here? Just think about it. Jennifer will need this much, right? And this is the face value that she signs, that the note has. So basically she'll pay back this one, she gets this one. So can you figure out how much the discount is? In other words, how much actually the bank earns, right? So the bid discount is actually the face value, which is the face value, which is 6355.81, minus how much Jennifer actually gets, so which is 355.81. So that's the bank discount, 355.81, divided by the maturity value is 6,355.81 times, okay, this is 250-day note. Again, make sure that you convert the 250 into number of years by dividing it by 360. And using your calculator, this actually turns out to be 0.0806. And we want to convert this into percent, which is 8.06%. And let's run to the nearest tenth, 8.1%. All right, so this is pretty much the first topic. We introduced the simple discount note, and through several different problems, we found the proceeds, we found the length of the loan, and we also found the discount rate, right? So we look at a variety of different problems. The next one is to find the face value to achieve desired proceeds. Suppose you want to get a certain amount of proceeds, the actual money you will receive, and then how much actually you have to pay back at the end. So this is the formula. Just quickly show you how this formula is derived. If you remember, proceeds is maturity value minus the bank discount, right? And what is the bank discount? You certainly, if you remember, it's going to be MDT. So I just plug in the discount. And in here, we see both terms have the M. So I'm going to factor it out, which means take it out. So when you factor out, we are left with 1 minus dt. Now, finally, you just divide both sides by 1 minus dt. That's what you get, right? P divided by 1 minus dt. That's what you get. So when you divide both sides by 1 minus dt, so this is gone. You see that M is P over 1 minus dt, which is this formula. Now, let's apply this formula. Jen needs $18,000 to prepare her web page design business for opening. So that's actually she needs. Her bank will loan her the money at the banker's discount. So at the banker's discount, that means you are going to use the 360 days and also discount rate, which means we are talking about simple discount notes of 10% for 180 days. Find the face value of the note so that she'll have the required proceeds of 18,000. So this is the proceeds. This is the discount rate. And this 180 days, that's the time, right? So therefore, the maturity value is going to be P over 1 minus dt. The proceeds is 18,000. 1 minus the discount rate is 0.1, 10%, times the time. If you use 180, you are wrong. You have to, hopefully you can quickly determine what you have to do. You have to divide by 360, okay? And this is going to be, actually it turns out to be $18,947.37 rounded. That means she gets 18,000 up front, and at 180 days, she'll have to pay back this much. Let's look at the next one. A 300-day note has proceeds of 48,000 and a discount rate of 8.8. we need to find the maturity value. And this is certainly the time. This is the proceeds. This is the discount rate. We want to find the maturity value, which is P over 1 minus dt. And P is 48,000. 1 minus the D is 0.088 times the 300 days. So 300. I hope that I have repeated enough number of times so that you do not forget to convert the time into the year. And from my own calculator, I get this. Oh, by the way, I do want to emphasize when you for this particular problem, if I were to type in my calculator, this is what I would do: 48,000 divided by, make sure you use parentheses, right? 1 minus 0.88 times 300 divided by 360. Okay, that's how I would enter that into the calculator. So this turns out to be $51,798.56. Again, always check my math. All right, that's pretty much for this new formula. We are gonna do a little comparison here. So two notes both have face value of 75,000 and a time of 90 days. The first note has a simple interest rate of 10%. That means the first note is a simple interest note. The second has a simple discount rate of 10%. That means the second one is a simple discount note. Let's identify which one is the better deal. That means which one you would get to your benefit. So I'm going to begin with the simple interest note, the first note, okay, simple interest note. And for the simple interest note, if you remember, the interest is actually PRT, which is P is 75,000. The principal, that's how much you get, right? Times the next one is the rate, which is 10%, so 0.1. And time is the same, 90 days divided by 360, converted into year. And this is actually $1,875. So basically, the borrower, that's borrower, okay, receives $7,500, and at the end of the loan period, this much interest will be paid along with this principal to the bank. Now, if you look at the simple discount note, what is the bank discount? That means kind of the interest charged by bank, which is the B. It's MDT. Because they have the same face value, that means here the maturity value is 75,000. And the discount rate is the same, right? Discount rate is the same, which is 10% right there, so 0.1. And the length of the loan is the same, 90 over 360, 90 days. And because it's identical, these two numbers are identical, so it will be the same number. So this is the bank discounts. Now, how much actually the borrower will receive, because this is a simple discount rate, a simple discount note, the proceeds the borrower receives will be 75,000 minus the bank discount, which is 73,125. So now you're gonna look at this yourself. You actually pay the same amount of interest. In the simple interest note, you get 75,000, and then in the simple discount note, you get $73,125. So think about it. Which one would you go with? I would certainly go with this one, right? Better deal because you receive more money and you pay the same amount of interest. Why you definitely this is a better deal, right? Okay. So yeah, that's this particular problem. It's an interesting problem. Now we are gonna close this section by looking at the very last topic, effective interest rate, also known as annual percentage rate, APR, or true rate. And this is the true rate. When you use the I equals PRT, simple interest rate, this is based on the actual amount received by the borrower. It's not based on the face value in a bank discount, in a simple discount note. So this is the true rate. Whenever you use this formula, that's the true rate. Now from previous example, we compared two, right? Simple interest rate, and we compare simple interest notes and simple discount notes. So in the simple interest note scenario, the true rate is 10%. That's the so-called APR, annual percentage rate. That's the true annual percentage rate. This is not. This is simple discount note. This is not. The 10% is not. Let's find its effective rate of interest for this scenario. Okay, for this scenario. So we are going to say, find the effective rate of interest for the simple discount note. So again, if you recall from last problem, the interest you have to pay back deducted by the bank is 1875. So interest is 1875, and the proceeds received is this much, right? Also, now just think about that's how much you get, 73,125. And the time is actually 90 days divided by 360, which is 1/4, a quarter, which is 0.25. Now we are gonna actually write, we have to use this formula to find the real APR. So therefore the real APR, which is rate, is I equal to PT. So I is 1875, P is 73,125, and T is 0.25. Now if you do the math, this is going to be 10.25%, will be 0.1025. I convert it into percent. So actually in the simple discount note in this scenario, the real, don't be fooled by this printed, the notes printed here. This is simply simple discount rate. This rate is not the real rate. The real APR is actually 10.25%. So hopefully you're a better informed customer now. So in the future, when you have to borrow a loan, when the bank offers a simple discount note, this is how you can actually figure out the real percent APR, the real APR, which is called effective interest rate. All right, this is it for this particular section.